Welcome, welcome. Um, yeah, so last time we were still working on trying to get these wall textures to render. We saw that if we waited for the OpenGL texture to get uploaded, we could see more stuff. Um, but we don't really trust the geometry right now. One of the things that is making it more difficult is that the texture we've been testing is mostly black anyways, and we're sampling that texture maybe incorrectly, and so just statistically, maybe we are doing the geometry correctly, but we might not see um, any non-black pixels. So uh, to address that, I think we should use find a debug texture. Like what comes to mind is a color picker. Um, like they have these color pickers. I'm just trying to think if there's a like in my mind it's like the rainbow, right? And then like luminance or saturation varying up here, and then shade varying in the X. And if we have all the colors, we should be able to, like this. We should be able to like use that as the texture and not have to worry so much about how we sample the texture so much as what the geometry is. And then the other thing I was thinking of is uh, if we're not sure about the geometry, it might make sense to not just look at the screen kind of head on, but look at the scene head on, look at the scene from the side, and look at the scene from the top. And then that will give us a better idea of if something is like incorrectly rotated. So let's try to plan that. Render walls is borked. Want a debug texture that is a color gradient so that regardless of where it samples, we see something, but also have some reference to see where in the texture we're sampling. Right? Now that's a lot of text. I don't know if that is going to be happy in my to-do thinger. We'll see. And then here, to avoid want a way to screenshot the scene from multiple directions to avoid notice misrotations more easily. Okay. So we should be able to get a little gradient going. textures, cobweb. Yeah, okay. So we're trying to like tweak our tests to see what we can see. Let us do this. I want to keep the res test room as it is because I only want one wall texture at a time. Let's run the tests. We expect a failure. So yeah. So now instead of the cobweb texture, what if we did def name debug texture? Let's keep it named the same way they name things. Debug space texture. X. We'll give it this one for now. Tab. Okay. Oh yeah, and this needs to be an object. Alright, so debug texture. Now the reason we could find cobweb is because somebody did a textures load all. There's a cobweb.json. This name should match the def name, and then there's a path. So data textures debug texture .json read data textures cobweb. There we go. Don't read the .png. Read the don't read the PNG file into a JSON file. Okay, so now we need to make a debug.ping. I don't think we... Licensing. That's one we got before, but I kind of don't like it. I feel like there ought to be a better one somewhere. How is it there not a better one? I don't want to make my own. Maybe we can take this one and then slice and dice it here. I don't like that. Maybe we can make our own. How hard can it be? So for each pixel, the luminance is controlled by the up and down. The hue is right and left. Can I see not your color picker? I don't know if that's a bug in Google search or what, but I don't like it. Color picker palette. Yes. Coolers. This is not helpful. Hmm. Mhm. How to generate color picker palette. Maybe I shouldn't say palette. Like, I don't want to muck around with paint and image magic, and let's try and time box it. Let's spend half an hour. Maybe we can make something with image magic. Image magic, generate gradient. Linear grid. Yeah. Okay. Um. Convert, no, Mogrify? Composite? Is this a, hold on. What is it? I'm kind of upset. Canvas. Is it? They keep saying magic, but it's not magic because it's... They broke out the commands into different sub-binaries. Maybe it's convert. Convert size 256. 64. 64. Radiant. Okay. So then there's that, and then there's Yeah. So go from yellow to blue. Compose with copy green, gradient black to lime. My goodness. I'm just looking for an example that I want. This is nice, except it wraps black to black. JPEG. Look at that. Okay. Licensing, I don't think we have to worry about. So let's not worry about it. Textures, debug.ping. Yep. Alright, and so then now we're going to draw the debug texture. So when we test, let's look at the reject file, make new rejects. So we see something, right? Looks kind of gray or something, but there's something. So this is, we were using the cobweb texture because, you know, why not? It was the first one in the res test anyways. But using this texture, we're going to have a lot easier time seeing if we've completely messed things up or if it's just weird geometry. Alright, so I'm just thinking, do I want to add this like temporary comment out the other wall textures to the Git history? We'll be right back. think I will just add it to the history. Debug. Add a color gradient texture image for open debug. Okay. So that's cool. Now, another question is, what do we expect to see? We expect to see this X says take the texture and draw it to the right of the room, which is to say the right of the image that is the floor, which is to say the right wall, like the wall to our right. If Y was more than 10, it would be above the floor image, which would mean on the left wall. So we're expecting to see this pretty low. And, you know, significantly up the wall. If the wall is, let's say, 10, so it'd be halfway up the wall. But we'd expect it to be, like, if you imagine the original image like this, we'd expect it to get kind of twisted, and then, sorry, I'm looking at it myself, twisted and sheared. So let's make sure it does that. Now, what should the geometry be? The geometry should be, we might not be able to do it quantitatively, but we should be able to do it qualitatively. So, like, if this is the room, right? Floor. I have an idea. Let's use the text tool. So if this is the floor, this is the left wall, this is the right wall. We would expect to see our, like, crazy guy, sorry. We'd expect to see our crazy guy kind of here, right? It depends on how big the wall is, right? How tall the wall is. I'm so good at drawing, by the way, in case you haven't known. Right, so the floor is going to continue out, you know, kind of goes off the screen on this. This is like the grid, right? The game grid. So there's 10 along here, and there's 10 along here. We don't know how tall the wall would be. Might not be a constant. You can imagine like a cave versus a crawl space, cathedral versus a bedroom kind of thing. So, you know, we'll call it H. How big is the thing we just made? Data textures debug. It's 100 by 100. Let's make it big. What is the scaling factor for these wall textures getting splatted against a wall? It's just like assumed to be the right size. They don't scale it. FRDX, FRDY. The float of the room's DX. I hate this variable name. Here's a question: what happens if we don't do the division by 100 and we do our test now? Will we see more of the texture? Yes. Now, what does this look like? This looks like we are almost mistakenly rendering the corner of the room. Let's not do division by 10 or 100. Maybe that's their way of like crisping things up. Take a big image and smush it into a tenth of its size, and that's what you sample? Yeah? I don't know. We were dividing these by 100. Now, if the wall texture's x-coordinate is larger than the room's width, we rotate it by minus pi by 2. We don't need to type it out. Math dot pi over 2. If the wall texture is positioned to the right of the room's floor, that means it's on the right on the wall to the viewer's right. Rotate it 90 degrees. Clockwise about the z-axis so that when we stand it up, the texture will be right side up with respect to the rest of the scene. Now this right here means when we stand it up, we need to first rotate it in Z by wall texture rotation, then rotate along Y to flip it up, then translate it. Okay. So the first thing we do is scale if we're flipping. Now, scaling minus x minus 1, 1. That is the scaling we need to do for a right wall. The left wall I don't like how they're doing this, because like the flip flips it horizontally when it's on the left wall, but it flips it vertically when it's on the bottom wall, or the right wall. That's jank. Not really, because the first thing we do is we flip it horizontally, or not. I see. The flip is really like a whether or not to flip the, I'm calling it a decal, horizontally. Whether or not to mirror the decal along a central vertical line. Whether or not to mirror the decal about a vertical midline. I think that's better. Okay. And then that makes more sense. And so whether we're right wall or left wall, the first thing we do is we flip it. So then the flip is taken care of. Then for the right wall, we rotate it in Z about WTR. So now This is going to be an extra 90 degrees from whatever kind of your tweak of a rotation you want to apply to the decal. So if you want to like take your cobweb and kind of tweak it a little bit, that's fine. But that's broken because this doesn't. Like if you want to twist if you want to rotate your decal by 90 degrees and you give it a rotate a 90, we're gonna rotate the whole dang thing to the bottom right quad of the screen and then the bottom left quad, and we're just not gonna see it. We're never gonna. It'll draw onto the floor. Kudu, Jiniki. I don't think we can combine the rotate my decal for aesthetics with the rotate the texture to align with the right wall here. For now, the original WTR had better be 0. For now, WT.rot had better be 0. Cool. So let's assert that, actually. If WT.rot not 0, panic. Bumped error F. We don't support non-zero rotations of the underlying decal yet. See number bug 11. We're just not going to have to worry about it because if somebody passes that in, we'll panic and forget it. Okay, so WTR, right? And then now here's the thing. Whether we're doing the floor or the left wall or the right wall, these... Oh! We support decals that are straddling a corner. Okay. Okay. So... Yeah. You can imagine a cobweb in the, like, the corner of the room. I mean, the corner of the floor with the wall, right? Like that, you can imagine a cobweb like this. Now, I think it'll draw it along the floor and then up the wall, which is a good approximation for now. But I think they're trying to do, like... That's why we do it for the floor of the wall. The floor of the left wall and the right wall. Because a piece of the decal might belong on that surface. Okay. Okay. Build geometry and build geometry for each of the 3 surfaces that might need to build geometry for each of the 3 surfaces that might have a piece of the decal. So first we build the floor stuff. Yep. Okay, okay. We're still working mostly on the right wall, which might be the hardest one. Lucky us. Okay. So the steps are handle the flip. Rotate such that the leftmost extent maps to the bottom of the image, and the rightmost extent maps to the top. The bottommost extent maps to the right hand of the raw image. The top maps to the left of the image. Yeah. So you can imagine, like, if you're drawing like an let's do it like this. So if you've got your Y, your X, and your Z, don't worry about Z right now. X and Y, right? The original image is something like going to be something like this, right? We're rotating it to this. The next step is going to be to pick this end up and rotate it along about the y-axis to like lift it forward in Z towards us, and then we're going to move it. So like, what's the next step? So then we go like this, you know, rotate, and then we do like a translate. I think that's what we're trying to do. And we're just, you know, gonna move it. We're gonna start out with the texture. Oh, in the middle of the. Oh, we don't. Okay. So it's not this image. It is this image. So it's centered at 0, 0. Then we rotate it by 90 degrees. So it goes like this. Okay. I mean, I guess I should do this. If this is the texture, right? What does that look like rotated 90 degrees? Looks like a bunch of 7s. Except it'll be like that. So this one will be like this. Nope. Sorry, this one will be like this. Why am I having such trouble? This one will be here. Oh, this one will be... Like this quad gets mapped to here, but rotated. Okay, okay. Because we center it at 0, 0, because the texture geometry is starts centered about the origin, we can combine any aesthetic rotations with the rotation needed to align our decal with the right-hand wall. Needed to align our decal how do I describe this? Yeah, okay. Blah, 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 blah. This vector here from 0 to the height of the room from the left top to the right top. I mean, anything that's above the room, get rid of it. From the left top, right top to the right bottom. I bet this used to be... Oh, sorry, I'm looking at it right now. This is the B, this is the A. So start at the right bottom, walk to the top right, and only keep things to the right of that. Yes. Start at the left top, go to the right top, only keep things that are below that. Does that make sense before we transform it to the... Okay, yeah. These are pre-transform. We also transform. Yeah, okay. So make a polygon of the transformed vertices. not sure about that. I'm not sure about that because that would be. Like the vertices in this polygon are going to be the screen space, or really world space vertices for the decal. Um, but these are in like the local space of the room. I mean, it's already broke. We can't break it anymore. So move the texture to its spot after we do the rotation. We haven't stood it up yet. Okay. Okay, we haven't stood it up yet. Okay. Okay. I'm starting to feel like it's a. I don't know if there's a term for it, but like, if you do, what's a good way to explain this? If like the floor, this, and the left wall is this, right wall is this. Right? It's really. It's like you have a piece of paper and you're gonna fold along these lines and you cut this out. Right? You fold this up there and this up here, and then you'll end up with a floor and some walls. I think, yeah, that's how I'm gonna think about it. I don't know if there's a name for that kind of like origami with instructions, origami instructions, but start out with the texture just centered in space. Apply a horizontal flip if the configuration tells us to. Rotate it in Z by whatever an aesthetic tweak they asked for. Plus, because this is the right wall, the like kilter over by 90 degrees. Yeah. And then move the kiltered texture to where it belongs in the exploded view of the world. Slice off things that aren't in that exploded out view of the world for the right wall. Right? Things that are too high are above this line. Things that are too far to the left, maybe they'd be on the floor, but maybe it could be right out of the room. But if they're too far to the left, they're out. And if they're too far down, they're out. clip out below the payload. We'll call it a payload. Clip out below the clip out whatever is below the end, the rightmost end of the wall to be. This is clip out whatever is we need names for this. Clip out whatever is to the right of the room. That is whatever is below the origami wall. Whatever is below the right wall, origami source, origami. In world space. That is, whatever is below the region that will whatever is below the region that represents the right hand represents the wall to the viewers right. Okay, so clip out whatever is to whatever is below the wall in world space. That is anything in the direction of the floor from the wall. Clip out whatever is I guess the world space, I'm assuming that the top is like to the top right. But that's not really correct. The top ends up being the top left. The top right is from the right. Let's just do it with like reference to the floor. So clip out whatever is above clip out whatever is north of the floor. It wouldn't be visible from in the room. It would otherwise end up displaying in the adjacent. It would otherwise end up in an adjacent room or floating in the void. How do I describe this? Is there a name for that, like, paper folding construction? Folding paper instructions. It's origami. I don't know enough origami. Is it like a structural decomposition? Structural decomposition of I'm assuming it's called decomposition. I don't know what it's called, but we'll say that it's, imagine a cutout. Imagine cutting the edges of a shoebox. Flattened shoebox view. Clip out whatever is too far north. Whatever is north of the top of the floor. It would otherwise end up anything in that region. Is outside the room. Yeah. Now clip out whatever is west of the rightmost edge of the floor. Anything in that region is maybe below the wall to be. The final wall. If you're looking at the wall, it'd be like down. So maybe it's on the floor, maybe it's out of the room, but it's not on the wall, that's for sure. And then clip out whatever is we go from right bottom to left bottom. Clip out whatever is south of the room. South of the bottom of the floor. Clip out whatever is south of the bottom of the floor. Anything in that region is outside this room. Is either on the floor or outside of the room. Neither of which are on the right-hand wall. Okay, okay. We're making sense. We're making sense. Now, indices, yeah, you're just drawing a rectangle over it. That's cool. It would probably be quicker to be like, eyes is a slice of unit 16. Do the allocation up front of, it's going to be 0, 1, 2, and then 0, 2, 3. And then for index in range eyes at I plus equals len of vs. Now the compiler will lift this, surely. But we don't know if this is correct because the polygon might have got clipped in a weird way. Okay, fine. Fine. Have it your way. Sure. If it's slow, we'll find it in profiling, and if we don't find it in profiling, it's not slow enough to care to bother us. All right. So, generate an indices buffer. It's kind of crazy that you got to do all this just to do that, but tis what it is. And now we inverse the matrix. So it'll take a point on the final wall and convert it to the original texture, like the original origin. Really? We may have clipped the entire decal. Only buffer data if there's a polygon left over. If there's still a polygon worth of points. If there's still enough points to make a polygon. I mean, there's nothing saying that the points aren't all the same. We may have clipped the entire decal out. Skip buffering data if there's nothing left in the polygon, as denoted by the length of the vertices of the polygon is 0, which is like an awful way to do it, but okay. So from 1 to number of vertices minus 1, draw a triangle from the first vertex to the ith vertex to the ith plus 1. That's I plus 1th vertex. It's like a triangle fan. If we've got like, oops, man. JS Paint. So what was I doing? If we've got a polygon, right? There's some vertices. It's a big vertex. Don't worry about it. All right. So pick one for the initial. It's here. So I guess we're assuming a convex polygon because we're drawing triangle here to here to here, then here to here to here, then here to here to here, here to here to here, here to here to here, here to here, etc. Right? It looks a lot better when it's a convex polygon. There. So let's try this again. Yeah. You get a vertex. You get a vertex. You get a vertex. If we say that this is the 0th, 0 to 1 to 2, back to 0. 0 to 2 to 3 to 0. 0 to 3 to 4 to 0. And you can see that we actually end up covering the extent of the polygon, right? So that's what these indices will point at. It'll point in that order of vertices. There's len of V's. Should be a len of P? No. It's so so the these is all the vertex we already have in our like accumulating buffer. So this is like the floor. These has the floor and the left wall right now, and it's not changing through this loop. These indices are pointing past the end of that array for now, until we add to it here. Yep. Okay. So we say run.inverse. So the run used to be the thing we transformed the polygon by to flip it, rotate it, and move it into position. Then we clipped things in P, and we're saying for every vertex in P, move it back. Sorry, V is the pre-image of that vertex. Okay. So for I in range of the polygon, pre-image is the vector so P at I can be polyvert, right? Looks like we don't use I. So for each polygon vertex, the pre-image is the inverse of some vertex from the polygon. Okay. And then we're going to append a vertex to the geometry we load that says your x position is f rdx. The right-hand edge of the room. Everything on the right wall exists at the right edge of the room. The polygon's vertex dot y. Okay, so the world space isn't kiltered over. It's up is up and right is right. Okay, so go up as far as the polygon vertex is up, right? Um, go along the wall as far as it's really like position along the wall as far as the polygon's vertex is above the edge of the wall. Away from position along the wall as far as the polygon's vertex is away from the rightmost edge of the wall. Now the Z the Z should be the same Z value as the corresponding piece of no. The Z should be how high up on the wall. Position the left-right position along the wall is how far polygon's vertex is away from the rightmost edge of the wall. The top to bottom coordinate on the wall is how far the polygon's vertex is from the bottom edge of the wall. This geometry is relative to looking at the shoebox model when you're looking directly at the floor, such that the walls are actually invisible because they're it's like looking at the edge of a piece of paper. Okay. This is, transform the texture source textures transform from 0, 0 origin to transform from centered at 0, 0 to an origin in the bottom left of the texture image. This is who the F knows to do. I mean, we can probably figure it out, right? So the Y of the room, FRY, is a float for the room's Y position. Float for the Y position of the room. I should call this room Y. Because this is give the room.x to room.y. Room x. Room y. Room dx. Room room dy. Yeah. Presumably the source images for the textures were much larger than the expected size of the decal. Maybe the source images for the textures were much larger than the expected size of the decal. Okay. Okay, this is very helpful. We're kind of doing some transforms here, and we're doing some transforms when we go to draw the wall, because this is just putting it in world space. The objective of this function is to build geometry in world space. Okay, so the Y position of the room plus the Y position of the polygon normalized to the line of sight texture. T2D. Dog is barking. Sorry, what? Oh, they're using a slice. They're keeping tracks of the slices of this flat array, so that when you update this or this, they see it. Okay, fine. They're aliasing it. Whatever. So where to sample the line of sight texture? Should be the Y component of where the room is positioned, plus the Y component of the transformed polygon vertex. Yeah, because like this would be relative to the room, so this is like a global. I don't know how LOSU and LOSV are really used, but it would seem like a fragment that we're shading on the wall needs in part some indication as to its visibility with respect to line of sight. So but that's line of sight with respect to the middle of the room. It would depend on how these are used in the shader. To do grok line of sight shading inputs. Okay, this is good. So now we know that the contents of these buffers, or I should say, this X, Y, and Z. Well, I guess this is all world space coordinates of this vertex. Yeah. Okay. So that's one piece of the puzzle. But the next piece is when we actually go to draw a room. We call draw wall textures. We call render wall textures. And we're like, okay, somebody ahead of time uploaded some geometry. Now is the time to tell OpenGL to draw elements. While taking into account things like zooming, things like where the camera's positioned, etc. So for each wall texture, great. Find out if we've initialized it or not. Initialize it if we need to. Great. Bind the data for that wall texture. Basically there's a texture, like a kind of wallpaper for the wall. Bind the texture associated. Find the texture for the walls. No, it's not a. Oh, sorry. It's not the texture for a piece of a blank wall. It is the texture for the decal. Find the texture for the decal / decoration. No, I'm just gonna call it decal. Sure. Select texture unit 0. Bind to the array buffer all dat vertex data. So any and all of the left wall, right wall, and floor geometry. Hey OpenGL, look for 3 floats three 32-bit floats for each vertex. Make sure that when you're looking through the bound buffer that you walk in terms of the whole room vertex values. And really you need to start in this buffer at unset offset of vert.x, namely the offset of this field, and then this will be sequentially stored. Okay. And then, hey OpenGL, there's texture data in the array buffer, and the buffer bound to array buffer. Each texture vertex has two components. They're both floats. Make sure you walk in step sizes of size of room vertex. And the first one starts at vert.u. Activate texture unit sub 1. There's more texture data. Again, 2 floats. Look for it in stride of size of room vertex, and the first value is at LOSU. Sure. Okay, select texture unit 0, texture unit sub 0 as the current texture unit. If there was any geometry for the floor, do this. There's not going to be. Right? There might be some. If there's going to be any geometry for the left wall, handle it. If there's any geometry for the right wall, set your stencil function to always let fragments through using a ref of value of 1. Set the indices for the right hand wall geometry to be the buffer we'll use when we're looking for indices, set GL color, draw elements, make some triangles, use as many elements from right buffer as we put there. They're each unsigned shorts. Start looking in the beginning of that buffer. So GL short had better mean 16 unsigned. Wait a minute. Yeah, unsigned short. Yeah. Short. That looks like a UN 16 to me. Okay. But before you draw the elements, we are going to use a particular matrix to transform our world coordinates. This is like world to view. This is a world to view matrix. Okay. Looks quite similar. And that's fine. We do like a minus 50 to plus 50. We rotate that. And we move it. Where's the room position? I'm just seeing like, what would the X and Y be for the room? It should be 0. We can... We ought to be able to show that. So the world to view matrix is really just the tilt kilter, or kilter tilt, whatever you want to call it. Okay. Okay. What? Let's not deal with doors. Sorry, make a new Lua table. Set count to 1 for each X, for each Y. Push point 1 X, Y, 2 X. Set table. Okay. I don't know what that is. board X, board Y. F. Rundown. Dimensions. If X is less than 0, Y or less than 0. Okay. Window to board. Oh my god. How am I supposed to know if that's correct? What distance? D to P. So there's a matrix, a point, and a ray. This is whatever you need to do to go from world coordinates to view coordinates. This is a vector column major order means 0, 1, 2, 3 is the first column. 4, 5, 6, 7, 8, 9, 10, 11. This is the fourth column, which is the translation. Yeah. So they're saying don't translate. Get the forward vector. Undo the translate. Project the point onto the forward vector. The distance divided by the cosine. I agree. I don't think I wrote that. I was there before. D to P just is not helpful. But I think we're just looking through what the sizes are. Okay. Um, we might need to abandon that kind of push, but we're getting stuff. We just need to make it the right stuff. All right. So here's a question: what did we expect in terms of the image? If we do this, what would we expect the image to be? I'll also come right back. we could just call render wall textures. But do they have some kind of matrix pushed? Yes. Did I break this before? Okay. This is where the bug got introduced. I think I did it. Oops. Okay. Let's unbreak that. What do we got here? Is it just logging and commenting? Mm-hmm. Docs. More comments. Sanity is improving. Let's fix my boo-boo. Okay. This should be unsafe dot offset of vert.x. Pointer. Yeah. Record a macro called, record a macro of k. Search for pointer open parent. No. Record a macro k. Search for pointer open parent dot star an ampersand vert. Okay. Go to the end of the line, reverse search for an ampersand. Switch it to unsafe dot offset of add a closed parent. Okay, so let us review all of the cases of vertex pointer, text coord pointer. So, vertex or text coord pointer. Yes, texture vert u, offset of, yeah, offset of vert LOSU, because we've bound the array buffer, right? If there's an array buffer bound, we pass in offsets. Ray buffer offsets. It was bad. We bound. Yeah. Okay. Okay. Mhm. 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 But how much stuff is broken now? No. We've lost the plot. Um. Oh look, we were on main all along. What? Get branch. Boop at that. February 26th. Okay, we don't need update Mathrio. Okay. Pretty sure who broke house wall texture in the last command. Saying we added the thumped import, but we didn't use it. Let's patch the old commit. Add it, commit, amend, no edit. Fine. Like we never made the mistake. Now, when we test here, what do we see? Similar. Okay. 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 That's okay. We're just calling render wall textures. We're not calling room render. And so what I'm thinking is that actually when we do this, we really need to do it inside of render.width matrix in mode, the floor matrix in render matrix mode model view. Actually, we do it like that. Okay, okay. So, it didn't change anything. Hmm. Oh. Because we are doing it here. Okay. So we don't need this. It's doing it already. Now when you normally get called, we'll have clobbered the model view matrix. But, whoops. Okay. sorry, the region is 10 by 10. Why? I think that's a different test. um, no. What? Make room mats for test. Where else do you get called? Drawing walls. Test make room mats. Make test run args is dash run test make room mats test it. Render.show mat. Okay. It says translate to adjust by the focus, but it's not translating to adjust by the focus. It's translating to adjust by the middle of the room. Translate to adjust to the middle of the room, then by the focus. Right? Okay. Try again. We don't need to trace this one anymore. So let's not. Someone is still passing 10 by 10. Okay. Non-zero zero focus. So this should also be 200 and 200. This is 100 and 100. Running test make room mats succeeds. What is focus doing? If anything. if anything. Alright, let's update the test to use a region of 200 by 200. Because why not? And reduce logging verbosity. Test. Tweak input regions for consistency and reduce test verbosity. Logging verbosity. Add house room, commit fix. When there is a buffer bound to array buffer, pointer defining functions, OpenGL's pointer defining functions expect offsets from the bound buffers. Start, not an absolute client side memory reference. Fix. Use vertex pointer and text chord pointer more right. Okay, so yeah. When we test, we get some rejects. Let us look at these rejects. Okay. We know this gets called, right? We see room go 342. GL state of this model view matrix, this projection matrix, we're trying to draw the debug texture, there's actually geometry in all of left, right, and floor, which is somewhat interesting. Um, let's only draw the right-hand side. We're gonna make test run args run just test room. Oh. Okay. Okay. Maka. That's res test. This is a legit 10 by 10 pixel friggin' room. Our rooms are just super tiny. But why? I mean, why divide when we can multiply by 0.0? Sorry, I've gone quiet, but I'm thinking really hard. um, Now that shouldn't change the span of the texture that gets blitted, but it should make the image bigger. So I think we're clipping wrong for the floor. Let us look at that. Floor. Wall textures. Floor. Floor. I can spell. Now, let us investigate this clipping. So start in the bottom left, go into the top left. Clip out things to the left of the floor. Start in the left top, go to the right top, clip out things above the floor. Start in the top right, go to the right bottom, clip out things to the right of the floor. And then start in the right bottom, go to the left bottom, clip out things below the floor. This is going to be polyvert, and P at I is just polyvert right here, and I doesn't need it. Okay, so V is the pre-image. Again, pre-image. So use the world space X and the world space Y. Texture it based on the pre-image X and Y. I'll be happy. Now this probably doesn't need to be negative anymore because I don't think we're loading our textures upside down. Now that should not have changed anything. But we seem to be clipping out the wrong piece. Perhaps we're performing the wrong transform. What is the transform that we're performing? We need to... We're going to transform all the vertices, namely the corners of the square texture. So if we need to flip, we flip it horizontally. If we need to rotate, we rotate. And and then we move it by WTX, WTY. What? So you're saying go minus 50 minus 50 to plus 50 plus 50, because TDX is just the width of the texture. Wait, are we logging TDX? We're not. Okay. We should log these things. Oh boy. Nope. Logging.trace wall textures setup GL stuff. All the stuff. Okay, so what are we doing? FRX, FRY, FRDX, FRDY. All the stuff. I just want to see if we actually see that. Foo, colon bar. Okay. So we can say FRX Y. DX, DY, TDX, TDY, WTX, WTY, WTR. So, record a macro called K, yank the word, insert quote colon space, exit insert mode, go to start of line. Done. Record K. Yank word. Insert quote colon space. Go to start of line. Let's just say any. Right? Let's just say any. Honestly, it's been so long since I was able to do any instead of interface open close parent. it makes me feel good to see that. So, all the things. All the stuff. 10 by 10. Positioned at 0, 0. Texture is 100 by 100. We are going to rotate by 90 degrees. And then we move it 15 to the right and ish and 1-ish up. These rooms are so tiny. Why? Why? Because it breaks stuff, it won't do that. We can't have nice things. I'm not allowed to have nice things. We're allowed to have that. Cool. Now, what was I expecting? Oh, okay. Let's not. And then deal with it. Now here's the thing. When I call room render wall textures, it seems to break other things. Hey, we seem to be leaking things. But look, there's stuff. Okay, I think I've had it for haunts today. but I wanted to try my hand at staying online and streaming something else. So bear with me. Close all this stuff. Actually, I take it back. I'm not gonna stream something else. I don't want to mess up the VOD and like have it be partly not haunts. So, thanks so much for watching. Hope to see you again next time.